The 62 set, it's an English set. It's actually a backpack. You can actually carry it on your back. It was put in jeeps, it was put on animals, it was dropped out of aircraft, all sorts of things. Basically, it's an upgraded 2 set. The English wireless numbering system started off with sets 0 to 9. Number 9 sets were put in tanks and armoured vehicles. Number 8 sets were carried on your back. Number 2 sets were portable sets. You'd carry them somewhere, set them up and use them. But as technology developed, they got lighter and better. So we've got a 2 set, let's improve it. What do we call it? We'll call it a 12. So they put a 1 in front of it. And then it became a 22 set, and the 22 set was very popular, and they were everywhere. Same thing happened to the number 9 set. Oh, we can build a better one, let's call it the 19. And let's call it 29 and so on. Same with the backpack sets. They were number 8, and then they became 18 in its 3 marks. And then they become 28, 38, 48, 58, 68, 78, 88. And at that point, they decided they were running out of numbers. They abandoned it and went to a different numbering system. This one is the 6th version of the 2 set, so it's a 62. Now, they were made towards the end of the war, and they were waterproof. They reckon you can put this in the water for 5 minutes. It's got a gasket around the edge. It's a waterproof case. And there are little gaskets around all the knobs and on the screws and around the meter. So you can actually put them in water for 5 minutes, but I wouldn't like to do that. They're not very heavy. They're 15 kilos, 30 pounds. And you can carry them for a short while, but not a long while. So it basically covers from 1.6 to 10 megs in 2 bands. Around about 7 megs, it's really flicky on the dial. You've got to be very careful tuning it. And it will do all of 1 watt ABM, CW and AM. And it doesn't vary much. Quite often sets go down to 1/4 power when you go from CW to AM. This one's much the same. It does about 1 watt AM as well. It operates from 12 volts, which is rather interesting. Most of the military sets operated from 24 volts in that era. And when you switch it to receive, you can just run it as a receiver. It runs on about 3 amps. When you switch it to transmit, it draws more current. And they're the dimensions. 20 inches by 10 inches by 12 inches and 30 pounds, 15 kilos. Now, they were made in the UK, but because of the problem the UK had supplying its own people, they sent a couple of examples out to Australia and we made them here. This is actually an Australian one. And if you look at the label, which is not very distinct, it'll say made by Pi, with an underline with a V under it. It was made in Victoria. And that's the way to determine that it was a locally made one. The English ones had a slightly different colour grey, but other than that, was very good, close copy. The other giveaway, it's full of Duke-on capacitors. So that's another giveaway.
What were the British ones, Hunts?
I can't remember. I don't have a British one. So I've only seen them. We used those for... Towards the end of the war, after the war, they were marketed by Pi to the police and the fire brigades and all sorts of things. So we never really had any British ones out here much.
Sorry, when were they made? What sort of year range were they?
This one's actually modified in 1955. They changed the plate when they modified it, they upgraded it. So it says 1955, but it's hard to know when it was actually made. Somewhere between 45 and 55. It's very clean inside with the gasket. It's lovely.
Is that an operating one?
This one was operating till I turned it on to come here, and now it's got a heterodyne, so I've got to fix it. So. But I've got two others. I've got 2 others down there. One on display, and that power supply blew up while I was using it. So I've got that on a battery at the moment, and I'm going to walk around with one at 11:30. We're going to have a 80 metre net on 3590, and I'm going to wear this, not this particular one, the other one that works. And there's going to be other people with BC611s and A510s and those sort of things. 11:30, 3590. We're going to start down at the historical radio, the military radio table there, and move out and talk for 5 minutes and come back. And then at 12:30, we'll do it on 6 metres. That's the Cold War net. So the first one was the World War II net. The second one will be the Cold War net, so you can use your PRC 25s. We'll be on 6 metres, 51 megs, FM, and the same deal. Then at 1:30, we'll be on the AirNet, so we'll be on 144.125 AM, walking around. Same deal. So where's all your radios? Come on. Not Yaesus or Kenwoods. So the control. So basically, this is the on-off switch. And you can switch it to receiver on. So it only, if you're only doing listening watch, you'll just listen to that. When you want to transmit, you'll flick it to the next position. It'll draw the 5 amps and the transmitter valves will come on, reduce your battery life, of course, and heat up the transmitting valves. So there's a meter here with a meter switch, so you can measure the input voltage, and it's got a little tag saying, 12 volts equals 11.75 or something, depending on the calibration. You can measure the receiver HT, the transmitter HT, the AVC, the aerial current, and the drive to the final valves for transmit. So it's by flicking that switch. The main tuning dial is here. It's got 2 dials, one either side, 1 to 4 megs and 4 to 10 megs. And you flick it with this switch here. Also, you can put a crystal in, and you can switch it from master oscillator to crystal if you want to be crystal locked. And the crystal just plugs in just here at the front. So they had discovered crystal stability by this time. Down the bottom here are 2 little 3-point connectors, and one will go to a calibrator, so you can just check the calibration of it, or if you want to set it to a specific frequency, you can do that with the calibrator. It's powered from here. The other one goes to a remote control box, and you can use it remotely. You can go to transmit and receive, and so you can have the radio somewhere and you can be up a tree or somewhere else and use it. So that's what those 2 connectors are for. The tuning has a what they call a flick stop. So you can tune it normally, or if you set it to flick or down the bottom here, you can just turn the dial around and it just goes clunk and it'll stop, and turn it to the next one, clunk. There's 2 click stops. So you can set up pre-set channels by loosening these 4 screws, and whichever click stop you're using is shown in this window, a red one or a yellow one. So you can get to various frequencies easily. You might want to change bands and go to a different frequency, night or day or something like that. So here's the gain control, which is a normal volume control on AM, and it's an RF gain control on CW. Here is a BFO control, so you can tune in CW, or it can get sideband on it, but it's a bit fiddly. And of course the mode control, you're normally on RT for AM. You can switch it to net, so you can tune for the minimum whistle and net to another station, or you can turn it to CW, and then the BFO control then works and allows you to vary the heterodyne to get the signal you want. There are 2 chords coming out here, these drop chords. No one likes them, but the idea is if you want to run away, you just start running and the chords pop apart. And they are waterproof as well. So there's 2 there, one might go to the key, one might go to the phones. That's the power input plug, so your 12 volts goes in there. Now the important thing about this radio is not only does it have the power supply inside, here there's a little dynamometer in there. so you don't have an extra box. It also has a roller inductor and a tuning capacitor. So you can match a whip aerial or a long wire aerial. So it's got a built-in ATU. Some of them have on the top, and the ones downstairs have it, they have a rubber mount here with a whip on it. So you can carry this one like this with a whip on the top and have the whip tuned properly by the ATU. So I think that's all the controls. Oh, there's a little window here showing you where the roller inductor is and a lock to, once you've got it set up, you lock it and hopefully it'll stay on tune. The whip mount goes on the side. So you can use the radio vertically like this or horizontally on the table. Depends on the size of the battery. I haven't used it for very long, probably an hour. Once again, yeah, it varies on the size of the battery, but if you've got a charger, it'll last forever sort of thing. So basically, it was an upgraded 22 set, but very different. So this one was made in reconditioned in 1955. There was a campaign throughout all the services to upgrade the radios around about the 50s. You'll see a little badge on them sometimes saying reconditioned 1955. All the World War II stuff was done that we had. This one, they just changed the plate here when they did it. So this is the power supply here under that pad. It's a small dynamometer. Later on, they had a transistorized inverter in there. So that was more efficient, didn't use as much power. This one's the dynamometer. You can spin up, takes a lot of starting current, but once it's running, it's fine. This here, this section, is the power supply filtering and the audio, and the drop cords come into this little tag strip here. The receiver is basically along here, and the transmitter is basically this area. And there's shielding all over the place and Duke-on capacitors in it.
Sorry, can I ask a question? So
Sure.
underneath that pad, was there like a little motor?
It's a little motor.
It's a motor generator.
Yep, so there's a,
Brushes on each end.
yep, so there's a motor on one end and the other end has HT brushes. So it's a DC to DC converter basically.
So what voltage was the output of that?
12 volts in, 250 out.
Is that for
Yep. Sorry?
what was that for the valve?
Yeah, for the valve HT, yeah. Yeah, yeah.
That was very cool.
The only other way in those days was vibrators or separate batteries, an HT battery and an L2 battery, filament battery and a high tension battery, or the dynamometer. So to get the thing running, really I just had to, on all these things, the moment you get a dynamometer, you pull it apart, check the brushes and do the bearings. Always do that. All the trimmers, this one's been tropicalised. All the screws have got dobs on them. The capacitors have sealed. So it hasn't been painted liberally with moisture and fungus proofing, but it's had a lot of it done. When I was testing it, it was running fine. I was tuning it up and doing things, and I noticed the transmit power was dropping off. And I found one of the capacitors was getting hot. Replaced that, it's been hunky-dory. So it's only been one capacitor in all of 3 sets that was faulty. Oh, that's amazing.
Are they the paper in oil ones or what are they?
They're sealed. I think they are, because they're all crimped on both ends. They're all sealed capacitors. So providing they don't crack and let the moisture in or the oil out, then they're pretty good.
Is there problems finding parts for?
No, I've got a lot of parts. Don't ask that question.
It's only other people that have trouble finding
So the receiver is along the side and here. So this is the RF amplifier, the mixer, the oscillator, and the IF amplifier and the audio. This is the 3-gang tuning capacitor, and here's the transmitter. That's one audio valve, the transmitter, this one, an EF50 and the final valve before it goes into the roller inductor and the tuning capacitor. Now the Mark I, when they designed it in the UK, it had a waist strap here, and it was a metal waist strap. And when they wanted to chuck it out of aircraft, they found that that wouldn't fit into their standard drop bag. So they designed the Mark II. One of the changes was, which I don't have on here, they had a fabric band, a fabric belt. So it would compress, and they also put a few ribs in. I think these are they, I'm not sure, just to make it a bit more steady and more robust for throwing out of aircraft. So basically it was a 2-man lift. One guy carried the radio, the other guy carried the battery.
I think I'd rather carry the radio. Were they lead acid in those days?
Yes, they were.
I'd definitely carry the radio.
The option was a third person carrying the pedal generator to charge the battery. So it could be a 3-man portable radio. So here's the whip on the top, and the whip can either be in there for when the radio is lying down or in there for when you're walking along with it. So these are the standard carry straps. It's got this built-in business on the back. So this was the first version. There were 2 gentlemen carrying it. And notice that the radio operator is at the front, and this guy's just carrying the battery. This one's slightly different. The radio's on a carry pack and it's been turned, and this guy's the operator and this guy's just carrying it. So they've changed their roles a little. This is out of Wireless for the Warrior by Louis Mulstead. Have you read his books at all? He's done a lot of books on English wireless sets. So the receiver's very sensitive. It's very good, even with a crummy little whip on it. And it'll do 1.5 microvolts. 1 watt AM or CW. It's easy to tune the whip just by, you can either tune for noise or put it on transmit and work your way up. And there are instructions actually in the book on where to set them approximately to start off with. Now, part of the problem is that it was all AM in those days. If you wanted CW, you had a problem. You actually had to turn the transmitter on, because then the BFO, which is part of the transmitter, would come on. So to listen to CW or to get sideband, you had to have the transmitter on so you could draw more current. And that's really a pain. You're tuning across the bands looking for AM signals. You find some sideband, you can't resolve it. Oh, I've got to switch the transmitter on. Wait 20 seconds for it to warm up and then you can resolve it. So it's not really a modern set. The IF is 460 kilohertz, not 455. So if you want to transmit, the crystal has to be 460 above the transmit frequency. So you can operate, receive and transmit on the one crystal. So as far as the receiver goes, the aerial comes in through the matching circuit, goes to the RF amplifier, goes into the mixer, the local oscillator, which is 460 kcs above, 460 kilohertz above the transmit frequency, the receive frequency, mixes down to the IF, and then goes into the second IF, and then goes into the detector, and then to the audio, to the headphones. When you go to transmit, they have to generate the transmit frequency. Now it's a true transceiver, which means when you dial up the frequency you're listening to, the transmitter is automatically on that frequency. You don't have a separate transmitter and receiver. And the way they do that is they take the local oscillator, which is used for receive, mix it with the BFO, and bingo, you have the transmit frequency. So you do a little bit of filtering, put it through a buffer, put it through the final amplifier, and it goes to the antenna. And the audio goes in to modulate the power amplifier.
What was the distance?
With 1 watt, they say 15 miles. But I think that'd be in the country with no noise, no switch mode power supplies or anything like that.
Well, switch modes weren't a big problem in World War II.
They weren't. They weren't. You'd be more likely getting shot at. So this is the circuit of the Mark II. Now I've got a pamphlet down there next to the other radio set with the Mark I circuit on it. The Mark II is different in that you can tell there's sloping wires in it, just the way they've drawn the circuits. That's the first obvious way to detect the difference. The other thing that's interesting is that the detector here is these two diodes for AGC and AM detection. But if you notice, the grid and the plate are grounded. They're not used. They were in the Mark I, they didn't bother with the Mark II. The carbon microphone goes in straight through the transformer, would have gone to there in the Mark I and back to the modulator, but in the Mark II it just goes straight through. So here's the mixer. There's the modulator. The RF amplifier, the mixer, the oscillator goes into the IF, second IF, detector, audio output to the headphones. The BFO can be injected, or this is the receive mixer, sorry, the transmit mixer, which has the BFO here into it, through the tuned circuits to the buffer, through the tuned circuits to the power amplifier, and here's the roller inductor, and there's the tuning capacitor, and this is the aerial current detector. And here is the Dynamometer, the motor, and the high voltage generator, all in one small unit. The filaments are in a receive and transmit arrangement, so you can switch either of them on when required. Now on some of them, the knobs were impossible to turn because there's a gasket behind there and the grease had turned solid. So I had to take the knobs off and repack the grease, and now they're fine. So all the knobs have glands on them, all the screws have glands on them, there's a gasket around the side, everything is waterproof for 5 minutes.
You haven't tested that?
No. Normally I get a radio and chuck it in the swimming pool, but I don't normally do that. The rubber on the drop cords has had it, so I've had to replace that. I had the correct wire, amazingly enough. Now on transmit, I couldn't get the thing to tune properly. When I had a whip or aerial, or I actually was going into a dummy load. Oh, there's the Dynamometer. So there's a motor on one end, the generator on the other with a little fan, and some filtering here. Now that thing is only, you saw it's only that big. It's only a small Dynamometer. That's redoing the drop cords with the appropriate 6 wire cable.
Looks like you use a car trailer wire.
You could, but that's made out of plastic.
Are you wanting to keep it rubber?
This is made out of rubber, yeah. So I used this test device, which is basically made for the Larkspur. That's the later version of English radios. And what you could do is plug all the cables in and test all the cables, and you flip this little chart over and it tells you what to do. But there's also an RF watt meter in it, which does 50 watts or 1 watt. So I put it on the 1 watt version and I could tune up 1 watt okay, but there was no measurement or very little movement of the meter. So I decided to pull the sensor apart, which is in that little box, and find out what the problem was. Must have been the diodes in there. So here are the diodes here in a little bridge arrangement. The wire goes through the centre of this inductor with a few turns on it. And there's a resistor and a capacitor. And so I replaced them one by one until I'd replaced all of them. And it was still not reading. So I read the manual very carefully and it said 6 ohms is what it wants. It doesn't want 50 ohms. So I got an American dummy load watt meter. And on this one, you can dial up capacitance and you can dial up resistance. And I found that at 6 ohms, I could get plenty of meter movement. So it was sensitive to the impedance of the aerial. So at 50 ohms, I got very little reading. At 20 ohms, I got a bit more. 10 ohms, I got a lot more. And at 6 ohms, I got plenty. So matching into a whip is fine. It just doesn't like matching into a 50 ohm aerial.
So it
was designed to match into a whip. Yeah. Now this is not the correct headphones. I don't have the correct one. The correct one actually has a microphone in the centre there. This is actually a wireless set 19 setup, but it works quite well. So this is a normal set of dynamic headphones with the correct connector and a carbon microphone.
Is that a straight number 13
No.
telephone style mic in there?
I'm sorry, it's a dynamic mic. It's not a carbon mic. So it's actually a dynamic mic. The key normally has a cover on it, and you can go off in the bush and send CW if you want. And also going back to that, can't go back to that. Oh, can go back to that. You can strap this onto your leg so you can send CW while you're walking along or sitting down. Or it likes to have a ground plane so you can put on an earth and spread it out so it'll get you better radiation resistance. This is a standard ground plane. So there are 4 wires in here. Yeah, 1 end, 2 end, 3 end. I can't see the 4th end. Is that it? That's it there. If you use the remote control, you can use headphones on it for a second operator. Somebody could be tuning it, somebody could be taking notes. The power cord is got 2 separate size receptacles on it, so you can't reverse it.
Can I ask a question? Sorry. So we're on this unit. Where's that like the ground plane and the antenna connection?
The antenna goes on here, and the earth goes there. Power goes in here on this connection. So when you have it in the box, you would have this going off to the ground plane, this going to the antenna, or would go through this hole to the whip here, a little short cable, and the power just goes through that hole onto there or through there. And there's a little clip to hold it on as well. If you're doing remote control work, you use this remote control set, and it's got a little generator in here so you can call up people, send a buzz, or there's 2 wires here so you can run that off to a telephone. You can plug in headphones. This goes into this unit, and the microphone goes into here. And there's a 3-pin plug for power because there's a buzzer in there. So you can use it as a telephone as well. The microphone's slightly different. It's got a 4-pin plug on it. And that's the 3-point cable for connecting to the control box. Not the control box, well, if they've got the control box next to it, yes, but the frequency setting unit. That's the calibrator. So you plug it into there and that powers that. So then you can put an aerial on Earth and tune up the frequency you want. So that's an accurate way of setting the frequency of this. This is the English one. Notice it's a different colour, a darker colour. I got this off eBay, some guy in the UK was selling it. This one's been hacked up a bit. But looking inside, it's identical. And underneath,